तो ये हमारा जेईई मेंस का नेक्स्ट क्वेश्चन है। क्या क्वेश्चन है कि जो एरोसोल है वो कौन से काइंड का कोलॉइड है। अगर ये आपको याद है कि एरोसोल क्या होता है तभी आप ये क्वेश्चन आंसर कर सकते हो, अदरवाइज आप ये नहीं कर पाओगे। तो एरोसोल क्या होता है, ये एक कोलॉइड होता है गैस में या फिर किसी एयर में। अगर हमारे कुछ सस्पेंडेड पार्टिकल्स हैं और वो सस्पेंडिंग पार्टिकल्स आपके सॉलिड भी हो सकते हैं और लिक्विड में भी हो सकते हैं, ठीक है। तो छोटे छोटे लिक्विड के ड्रॉपलेट्स हों या फिर सॉलिड के कुछ फाइन छोटे छोटे पार्टिकल्स, तो उनको हम बोलते हैं एरोसोल। जैसे अगर आप एग्जांपल ले लो एयर का, अपनी जो नेचुरल एयर है इसमें आपके कुछ फाइन डस्ट के पार्टिकल्स होते हैं या फिर आपकी वाटर की ड्रॉपलेट्स होती हैं, ठीक है। तो ये किसका एग्जाम्पल है, ये दोनों किसके एग्जाम्पल्स हैं आपके एरोसोल के। तो इसका जो इसमें आपका तो मतलब इसका आंसर लिक्विड इज डिस्पर्स्ड इन गैस भी हो सकता है और सॉलिड डिस्पर्स्ड इन गैस भी हो सकता है, लेकिन हमें इन दोनों में से सिर्फ एक ही चीज दी है, वो है सॉलिड इज डिस्पर्स्ड इन गैस। तो इसका जो आंसर होगा वो होगा आपका सेकंड ऑप्शन।
Hello students, let's move to the next question. Adsorption of a gas follows Freundlich adsorption isotherm. X is the mass of the gas adsorbed on mass m of the adsorbent. The plot of log x by m versus log p is shown in the given graph. X by m is proportional to. So students, we have been given a graph, a plot, yes, and here the slope of the graph has been already marked, yes. Now accordingly we have been given four options as to what would be the parameter to which x by m would be proportional, yes. Now in that case, of course, pressure is the component, but then what would be the power to which pressure would be raised? Okay, now the very first question would be as to what is Freundlich adsorption isotherm. Just a small recall you guys can have now. So Freundlich adsorption isotherm. Isotherm means the plots which take place at a constant temperature, or rather we plot them at a constant temperature. Yeah. So basically Freundlich adsorption isotherm is an empirical relation. Yes. Let me just correct the spelling. Yeah. So it's an empirical relation between the quantity of the gas adsorbed, yeah, of a particular gas which is under study, which is adsorbed, yeah, into a solid surface, and of course the gas pressure. So as you can understand this statement, it says that it's the relation between the quantity of the gas adsorbed, okay, which would be indicated by mass, okay, and the gas pressure, the pressure at which the gas is operating, yes, or being observed under a particular condition. So there is an equation which is stated or which is given by this Freundlich adsorption isotherm, and that is x by m is equal to k is of course a constant, into p raised to 1 by n. Now in this case, x is nothing but it's the mass of the adsorbing. So the mass which I was trying to, the quantity which I was trying to indicate, here it is going to be the mass that is indicated by x, yes. So that's the mass of the adsorbate. Next is m, yes. M will be the mass of the adsorbent, yes, okay. Then P would be obviously the equilibrium pressure, yes. And K and M are going to be constants. So the constants are definitely going to depend upon the nature of the adsorbent and the gas at a particular temperature. Okay. So equilibrium pressure of what? Of the gas, of course. Okay. Now from this particular equation which I have put up over here, and of course which is stated by Freundlich adsorption isotherm, we can apply log on both the sides. Okay. So we'll be getting log x by m is equal to log k plus 1 by n log p. Yes. Now, furthermore, as we can understand, we know well that this represents actually the equation of a straight line, which says its y is equal to mx plus c. So on y-axis, obviously, we can have a look at the graph which has been given to us. On y-axis, I have log of x by m. On x-axis, log p. Yes. And log k is nothing but the y-intercept which we'll be getting. Yes. And 1 by n is the slope. Okay. So now in this case, as we can understand over here, x by m is y. Okay. And we have been asked as to how is, to what is x by m going to be proportional to, isn't it? Let us just recall the question once. It is asking us as to what is, yes, x by m going to be proportional to. So let us solve this now. Furthermore, now since x by m is y, okay, and your 1 by n is the slope. So 1 by n is the slope, which in this case is equal to what? 2 by 3. Look at the graph once again. Yes, it is 2 by 3, isn't it? 2 is this value, 3 is this value. So in that case, if it is 2 by 3, then we can say that n is equal to 3 by 2. Yes. Now if n is equal to 3 by 2, so x by m in that case will be equal to k into p raised to 1 by n. Or otherwise I can say x by m would be proportional to p raised to 1 by n, and 1 by n is what? 2 by 3. Yes, okay. So I hope you understand this 1 by n. Yeah. So in that case, 2 by 3 is option number 1. So the final answer is marked by option number 1, and it says that x by m will be proportional to p raised to 1 by n, that is 2 by 3, p raised to 2 by 3. I hope you understood the explanation. Thank you.
So here is a passage that is the clouds consist of charged particles of water disposed in air. Some of them are positively charged. Others are negatively charged. When positive charged clouds come closer, they cause lightning and thundering. Whereas when positive and negative charge collide, come closer, they cause heavy rain by aggregation of minute particles. It is possible to cause artificial rain by throwing electrified sand or silver iodide from an aeroplane and thus coagulating the mist hanging in air. Now here it is asked that AGI helps in artificial rain because, so first of all, what is coagulation? So coagulation is accumulation of particles. So coagulation is accumulation of particles, and they also settle down with the effect of the gravity. Now here it is asked that how AGI helps in artificial rain. Now I will tell you the functioning of silver iodide. Silver iodide, that is AGI. Okay, now first of all, AGI is released by a plane. It is released by plane. Now here are some particles of AGI. Okay, and they get raised into the clouds. Raised to the clouds. Now these particles get into the targeted clouds. After that, the AGI here causes the cloud moisture freeze, and after freezing they create AGI causes the cloud moisture freeze, and after freezing they form ice crystals. Now, with the help of this ice crystal, they grow enough big, and then they fall as snow and rain. They grow enough big and then they fall as rain or snow. So now generally the coagulation or accumulation of particle has taken place. So in this whole process, coagulation or accumulation takes place. These ice crystals become so heavy that after some time they melt and comes out on the earth as rain. They fall on the earth as rain. Now these ice crystals are similar to ice. So here AGI is used for producing artificial rain, and this is known as cloud seeding. Now here AGI is used for producing artificial rain, known as cloud seeding. And this phenomena is called coagulation, and here it is coagulated with the mist present in the air. So the phenomena is called coagulation, and here it has coagulated with the mist present in the hair. So this whole process is done by coagulation. Now moving towards your question. Ask that AGI helps in artificial rain because it helps in coagulation. So your option C is your correct answer.